So this last lesson, we've done how to find missing angles and sides in a single right triangle using trigonometry. And then we've done a little bit of problem solving with it as well. Last thing we're going to look at, what if we had two right triangles? Okay. How do we solve problems using trig if there's more than one right triangle? So really the best way to do this is just work through some examples. And then use some logical thinking. So in this one, we're asked to find the length of CD. Well, here's CD. And it's part of this right triangle. If you look at that, do I have enough information in that one to find CD? What's the only thing I know in that purple triangle? What's the only thing I know? What am I given? The angle, right? But don't I need at least an angle and a side? So I don't have enough information. But can I use the other right triangle to find some information about the purple one? What triangle in the red one, sorry, what side in the red one is part of the purple one? Yeah, well, the hypotenuse of both, or PD or BD, right? So if I can find BD using this, because I've got enough information in this, I can then do trig again to find the missing side CD, which I'm asked to find in the first place. So the first thing I need to do is find BD. How would you do it? Anybody got the equation? This is the angle I'm given. What's the name of this side? Opposite. What's the side I'm trying to find? Hypotenuse, which means sine. So sine of the angle, which is 47 degrees, equals the opposite side, which I'm given as 4.2, over the hypotenuse, which is what I'm trying to find. And you should be comfortable with how to solve this now. First of all, I have to times both sides by BD to get rid of the fraction. So I'm left with BD times the sine of 47 degrees is equal to 4.2. How would I get BD by itself? Divide sine 47. And whatever you do to one side, you do to the other. Also go. And BD is going to be 4.2 divide sine 47 degrees, whatever that works out to. Nearest 10. So one decimal place. Sorry? 5.7. Okay, yep. So now we've got this. Now I have enough information in the purple one to find CD, which is what I was asked to find in the first place. So now we can go ahead and find CD. So now you're focusing on this right triangle. Sort of find CD. I think I said E. So here's our angle. What's the name of this side? Adjacent. What's this side that I'm given? Hypotenuse, so that means cosine. So the cosine of 26 degrees is equal to the adjacent side, which is what I'm trying to find, CD, over 5.7. What do I do next? Multiply both sides by 5.7 to get rid of the fraction. So that means CD is going to be 5.7 times the cos of 26, rounded to 1 centimeter. Which will give it 5.1. And there were units, so we want to make sure to have that in. Okay.
Wait, so you multiplied 5.7 by
Cos 26. Yes. Just to get CD by itself, we times both sides by 5.7. Okay. So really, you can kind of think of it when you have two right triangles, you're doing trig twice. Or you're going to have to do trig twice. Again, we've got two right triangles here. This time we're asked to find the angle labeled X in this right triangle on the right side. If you look at this right triangle, to find an angle, I need two sides, but I'm only given one side. So I can't use trig right now. But can I find something first? What side? What side should I find first? WY. Because it shares a side with the purple triangle, right triangle, the right triangle on the right side. Okay, so to find this side, here's my angle that I'm given, my acute angle. What's the name of this side? Focus on this right triangle. Adjacent, this side, which means cos. So cos of 65 degrees is equal to the adjacent side, which is WY, divided by the hypotenuse. Get rid of the fraction by multiplying both sides by 15. That gets WY by itself. So WY is going to equal 15 times the cos of 65, and we can go nearest. The other ones are to the nearest whole number. So what's this one to the nearest whole number? 6. Now we're ready to find angle X. Because we know this side is 6. What trig ratio? This is the hypotenuse, so that takes out tan. This is the adjacent, so that does the cos. So the cos of the angle, which this case is unknown, equals 6 over 9. How do I find the missing angle? I got to do cos inverse to both sides to get X by itself. So X will equal the cos inverse of 6 divided by 9, and it says nearest degree, so that's nearest whole number. 48. Thank you. Okay. Those ones, the two right triangles shared a side. Here's one where you've got one of the right triangles inside the other. Okay, we've actually got two right triangles here. We've got this one, where this side is 25.5, and this angle here is 50 degrees. And we've got the big one, where this side is also 25.5, but the big angle here is 70 degrees. Somehow I have to use all the information to figure out AB. So this is what I'm trying to find. Well, AB is part of the triangle. It's part of this triangle here, but that's not a right triangle. So I can't use trig to find it. I'm going to have to use the other sides. Can you see how you would find this side? What would you do? Think here.
You find BC
You can find BC,
and then find AC.
and you can find AC, and then you subtract the two. That's right. So AB is going to be the long side in the one that I've drawn in red, AC, minus the one I've drawn in purple, BC. So again, we've got to use trig twice. So we're going to find AC first. So you're going to focus on the big one. So the angle I'm given in the big one is 70 degrees. This side is 25.5. I'm trying to find this side. So looking at the 70-degree angle, what's the name of this side? Sorry? Opposite, yes. And this side? Adjacent, which means tan. So the tan of 70 degrees is equal to the opposite side, which is what I'm trying to find, over the adjacent side, which I'm getting. Get rid of the fraction by multiplying both sides by 25.5. So therefore, when I got AC by itself, when I did that, and AC is going to be 25.5 times the tan of 70. And let's go one decimal place. 70.1. Thank you. So this side is 70.1. And now, focus on the smaller right triangle that has an angle here of 50 degrees. And use that to find BC. So, it's going to be tan again, but this time it's going to be 50 degrees equals BC over 25.5. Times both sides by 25.5, and that gets BC by itself. Therefore, BC is going to work out to approximately 30.4. Thank you. So that's 30.4. And now we use subtraction to find what we were asked to find in the first place. So AB is going to equal 70.1 minus 30.4. And that should give us 39.7 centimeters. Okay. These last two involve angles of elevation and depression. We already talked about what an angle of elevation is. Okay? An angle of elevation is when you've got some object or person here, and then you've got another object or person higher up and away. The angle of elevation, you always draw a horizontal, which is where you would normally look, and the line of sight looking up to the object or person. That's an angle of elevation. We talked about this. Depression, you've got an object or person, and it's looking down at another object or person. So again, you've got a horizontal, and then you've got a line of sight looking down. That is the angle of depression. So you need to be familiar with how to identify those two. In this problem, you're given. Okay. So we've got a surveyor who's here on top of a 20-meter building, and they're looking at a taller building away from them, and they know that the angle of depression, if they look down to the bottom of the building, is 15 degrees. And if they look up to the top of the building, the angle of elevation is 30 degrees. Given that information, this, and this, I have to figure out the height of the building, the taller building. So I'm going to call this H. That's the ultimate goal. Any ideas? On this? Yes, absolutely. You need to find this. Because if you think about it, if we're going to find this, well, I already know this. How much is that? That's 20. But it's this I don't know. So I'm going to call it X. So I need to figure out what X is, add it to 20, and then I've got the height of the taller building. Well, in order to find what X is, I need to use this right triangle with the angle of elevation. But to do that, I need to use this right triangle with the angle of depression, because remember, this is also 20. Should have done it in two different colors. So remember, this is 20 here as well. To find this missing side, so I'll use another variable, call it Y. So we need to find Y, then X, then H, which is, like I said, our ultimate goal. So focus on this right triangle here. 15 degrees is the angle I'm working with. the name of this side is to 15 degrees. Opposite adjacent hypotenuse. Opposite, the name of this side, adjacent, which means tan. So the tan of the angle I'm given, 15 degrees, is equal to the opposite side 20 over the side that I'm trying to find. First step, get rid of the fraction. That's not going to isolate y. That's going to leave me with y tan 15 degrees is equal to 20. So now to isolate y, I have to divide both sides by tan 15 degrees. That will isolate y. When I do 20 divided by 10, 15. And it says nearest tenth of a meter, so I'm going to answer this to the nearest 10. Y works out to approximately 74.6. Okay, so that's 74.6. Now, I've got enough information here to find x. Well, that side's x. So focusing on this right triangle with the angle of elevation. The side x is opposite. The side that I just found from the lower right triangle is 74, which is adjacent, which means tan again. So this time it's going to be the tan of 30 degrees equals opposite x over adjacent 74.6. One step to isolate x, and that's to multiply both sides by 74.6. So x is going to be 74.6 times the tan of 30, 43.1. Now I can finally find h. Because this is 43.1. Therefore, the height h is going to be 43.1 plus 20. Which gives us 63.1 meters. Yeah, meters. There's the ones. Okay. So they get a little involved. The last one. Okay, we've got a observation tower. Can I get that? Oh, I was confused with fire. Fire ranger sees two fires. One directly to the west, and the angle of depression to that fire is 5 degrees. One directly to the south, and the angle of depression of that is 2 degrees. Somehow, we have to take all this information and find how far apart the fires are. That's the ultimate goal. So I'll call it D for distance. And we do know that this is 90 feet. Well, somehow I'm going to have to use the 5 degrees and the 2 degrees. Because what I need to find is the distance from the tower to this fire, the one that's to the south, and then the distance from here, the one that's to the west. So I gotta find this. Well, here's a right triangle. Okay. And that is a right triangle. I know it looks slanted, but it is a right triangle because the ground is perpendicular to the tower. I know that this is 90. What do you think this is? 2. Because if you think about it, the angle of depression when you look down at something is the same as the angle of elevation when this something down here looks back up at you. These two are the same. These are equal. So if the ranger is looking down at a fire and the angle of depression is 2 degrees, then the fire looking back up at him is also 2 degrees, which means I have enough information to find this. So I'll call this, I'll just call it X. So focusing on that purple rectangle. Here's the angle I'm given. What's the name of this side? 90. Opposite, what's the name of this side? Adjacent, which means tan. So to find the horizontal distance from the tower to the first fire, tan 2 degrees equals 90 over X. Times both sides by X to get rid of the fraction. That doesn't isolate the variable yet. So I've got X times tan 2 degrees is equal to 90. To get X by itself, I divide both sides by tan 2 degrees. And I can do this to the nearest foot. Okay, done.
2,577.
2,577. Good. So that's 2,577. Now we pretty much have to do the same thing to find the horizontal distance from the tower to the second fire that's due west. Again, that's a right triangle. This is still 90. This is what I'm trying to find. So I'm going to call that one Y. If the angle of depression looking down is 5 degrees, then the angle of elevation looking back up is also 5 degrees. So there's my information. So the equation is going to look like tan 5 degrees equals 90 over Y. Times both sides by Y. Get Y tan 5 degrees is equal to 90. Divide both sides by tan 5 degrees to get Y by itself. And y to the nearest foot. Works out to
1,029.
1,029. So that is 1,029. Now what? What kind of triangle is that? Remember, this is south. This is west. What's the angle between south and west? What's the angle between any direction and one beside it? It's always like here's north, here's west, here's east, here's south. These are always 90 degrees. All of them. So that means this bottom triangle is a right triangle. Now what would you do? I know this side is 2577. Pythagoras, yes. A squared plus b squared equals c squared. If you know two of the sides, you find the third side using Pythagoras. So the last step, 1,029 squared plus 2,577 squared is equal to d squared. So when we square those, let's save ourselves a step. Square them and add them together. So 1,029 squared plus 2,577 squared gives us a big number. 7,699,770. Therefore, D is going to equal the square root of 7,699,770. And that's finally going to give me my answer. And it works out to approximately 2,775 feet. Okay. That's the most complicated you're going to see. Okay.